Good morning to all. Myself Sajini John. In the previous classes, we have learned about matrices. Multiplication of matrices, addition, subtraction, order of a matrix, different types of matrices, all these things. Now, we are going to learn about linear inequations. Linear inequations in one variable. Okay. Then, before studying that, what is an equation? You have learned many equations, linear equations, quadratic equations, simultaneous equations, all these things, and identities. Identities a plus b the whole square is equal to a square plus b square plus 2ab. It is also an equation, right? Now, we are going to start inequations. Let's see. A plus b the whole square is equal to a square plus b square plus 2ab. On both sides, left hand side and right hand side, in between there is a sign equal to. Therefore, it is an equation. Suppose the values, consider value of A is 100 and value of B is 2. Now we can substitute these values here. You can see 100 plus 2 the whole square, that is 102 the whole square is equal to, instead of this we can substitute these values. Okay. Now we get 102 the whole square is equal to 10,000 plus 4 plus 400, that is 10,404. Now, if we remove this 400 from here, can we put equal to sign here? We can remove this 400 from this equation. Now, left side is 102 the whole square, that value is 10,404. Now, what is the value of right side? If we remove 400, we get 10,004. At that time, we cannot put an equal to sign in between. We can put a greater than sign. 10,404 is greater than 10,004. This is what inequation. Okay. Both sides are not equal. We can use some more symbols. Which are they? Greater than sign, here we used less than or equal to, greater than or equal to. All these are symbols for inequations. You can see here two variables, x is greater than y, x is less than y, x is greater than or equal to y, x is less than or equal to y. All these are inequations. For example, x plus 7 is greater than y. It is an example for inequation. And here 2x plus 3 is less than 15. That is also an inequation. Now, we can study how to solve a linear equation algebraically. Before that, there are some rules for transferring a term from one place to other place. In this question, we can easily transpose 3 to the other side or subtract 3 from both sides. The same thing, no? Therefore, 2x plus 3 minus 3, at the same time 15 minus 3. Or this 3 can be transposed from here to right side. We get 2x is equal to 15 minus 3. Right? So, 2x is less than 15 minus 3 is 12. 2x is less than 12. In this way, then we can find what is x. X is 12 by 2, which is x is less than 6. We will get the value like that. x is less than 6. But we can see the rules. First rule is, we know 8 plus 2 is greater than 6 because 8 plus 2 is 10, which is greater than 6. Now, on transferring a positive term from one side of an inequation to its other side, the sign of the term becomes negative. Okay, from here to here, the sign becomes negative as usual. So, 8 is greater than 6 minus 2. That is also true because 8 is greater than 6 minus 2 is 4. 8 is greater than 4. No change in the sign there. And second rule, if a negative number, when transposing a negative number from one place to the other, one place means one side to the other side, that sign changes. It becomes positive. So 8 minus 2 is 6. 6 is greater than 4. Then 8 is greater than 4 plus 2. 4 plus 2 is 6. Again 8 is greater than 6. Now we can see multiplication and division. Here, look, 8 is greater than 6. The same example we can choose is 8 is greater than 6. Multiply this by a positive number. A positive number. That is very important. A positive number. Now consider 2. Positive number. 8 into 2, 16. Here 6 into 2, 12. Again 16 is greater than 12. So there is no change. That means the rule is, if each term of an equation be multiplied by the same positive number, the sign of the inequality remains the same. The same thing in division also. You can see division. 8 is greater than 6. If we divide both sides by 2, what will happen? Here again 2 divided by 2. 4. Here we get 4 and here we get 3. Again 4 is greater than 3. So, if an inequation on both sides we are multiplied or divided by the same positive number, the sign does not change. Now we can consider, if the inequality is multiplied by a negative number, what will happen? We can see. Look, again we are taking the same equation, same example. 8 is greater than 6. Multiply this by a negative number. Consider, multiply these two by negative 1, not minus 4. First we can multiply by negative 1. Negative 1. Now left side becomes minus 8 and the right side becomes minus 6. Now what is the sign in between? Obviously we know minus 6 is greater than minus 8. So the sign reverses. Look, here these two numbers are multiplied by an integer, negative number, negative integer. So this becomes 8 into minus 4 becomes minus 32. Right side, 6 into minus 4, it is minus 24. We know minus 24 is greater than minus 32. In this case, the sign reverses. The same thing happens when an inequality is divided by the negative number, by a negative number. Look, look here, again 8 is greater than 6. Divide both sides by minus 2. What will happen? 8 by minus 2, here 6 by minus 2. Here we get minus 4, here we get minus 3. Which is greater? We know minus 3 is greater. So this sign reverses. These are the rules. Okay, now consider one inequation. You can see one question. 5x plus 4 is less than or equal to 24. We can solve this. Now 5x is transpose 4 to the other side. 5x is less than or equal to 24 minus 4. It becomes 5x is less than or equal to 24 minus 4 is 20. Therefore, x is less than or equal to 20 by 5. That is 4. We get x is less than or equal to 4. In this case, we are taking the values of x from a replacement set. Now we can see what is a replacement set. Replacement set means the set from which the value of the variable x is to be chosen. That is called a replacement set. Now you have to remember the number system. In a number system, you can see you already learned that set of natural numbers, set of whole numbers, integers, then real numbers, these things. Okay, now which are the set of natural numbers? Set of natural numbers 1, 2, 3, etc. 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 That is set of natural numbers. Then what is set of whole numbers? Set of whole numbers 0 together with the natural numbers. That is 0, 1, 2, 3, etc. are whole numbers. Then integers, they are whole numbers together with the negative numbers. That is etc. 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 from minus 2, comma minus 1, 0, 1, 2, 3, etc. These are integers. Then real numbers. The real numbers are all these numbers and including that fractions, decimal fractions, all the number system. All numbers that are real numbers. And in the previous question, we saw that x is less than or equal to 4. Suppose x belongs to natural numbers, we can easily find the values of x. X belongs to natural numbers. Suppose x belongs to natural numbers. Which are the values of x? Suppose x less than or equal to 4. Up to 4. And x belongs to natural numbers. Therefore, the values of x are 1, 2, 3 and 4 also, because less than or equal to x. Up to 4. Okay. Now we can solve some inequations. Suppose one question is there. 5x plus 3 is less than or equal to 2x plus 18. And x belongs to natural numbers. So you have to remember the rules behind it. So first we can transpose the term containing x to one side. Here 5x minus 2x is less than or equal to, here 18 and transpose plus 3 to the right side becomes 18 minus 3. So 3x is less than or equal to 15. Therefore, x is less than or equal to 15 by 3. That is, x is less than or equal to 5. And the condition is given, x belongs to natural numbers. Here, replacement set is natural numbers. Set of natural numbers. Therefore, we can write the solution set. What is solution set here? You have to write solution set in set form, either in tabular form or in set builder form. Here we can write the answer in tabular form because only 5 numbers are there. X is less than or equal to 5. So 1, 2, 3, 4 and up to 5. The values of x are 1, 2, 3, 4, 5. And write these numbers inside curly bracket. That means in set form. Or we can write this in set builder form. Do you remember how to write in set builder form? In 6th standard, I think 6th standard, you have studied set theory. So set builder form, x such that x less than or equal to 5. At the same time, you have to write this condition also. X belongs to n and close this curly bracket. That is a must. And this is also, when you write in set builder form, you have to follow this, all these things. Curly bracket and x belongs to which group, everything should be there. Otherwise, you will not get mark. Now, we can see one more question. A simple question. 7 minus 3x is greater than or equal to minus 1 by 2. X belongs to whole numbers. It is better to transpose the term containing x to the right side because here negative sign is here. Before x, it is negative sign. It is better to transpose this x to the right side, then it will be positive, and this to the left side. Then if you're doing like this, then don't bother about the rule of transposing or multiplying by negative number, dividing by negative number. So do in this way. This is more easier, and you can transpose minus 3x to the right side. You will get 7 plus 1 by 2. Transpose this to the left side at the same time. Transpose 3x to the right side. You will get this term. Now, it is when you simplify, take LCM. LCM is 2. 2 into 7, 14. 14 plus 1, 15 by 2 is greater than or equal to 3x. Now, transpose that 3 to the left side. It becomes 15 by 2 into 1 by 2. Then when we simplify, we get 5 by 2 is greater than or equal to x. What is 5 by 2? It is 2.5. Okay. X is, so here this x is less than or equal to 5 by 2, which implies x is less than or equal to 2.5. Okay. And we know x belongs to whole numbers. X cannot be 2.5. Why? What's the reason? 2.5 is not a whole number. So x is less than or equal to 2.5. In this case, the value of x will be, which are the numbers? 0, 1 and only up to 2, because 2.5 is a fraction. It is a real number. Okay, the value of x, the values of x are 0, 1 and 2. So this is the solution set. Suppose the other method also I will show. You just see. Suppose we are transposing 7 to the other side. We can see what will happen. You can see all these steps. Look here. Minus 3x is on the left side itself, and you can transpose 7 to the other side. It becomes minus 7. When we simplifying, we get minus 15 by 2. Transposing 3 to the other side, we get we cannot transpose minus 3 to the other side. Here we are using divide both sides by minus 3 At that time, by that rule, the sign reverses. Okay? Inequality sign reverses. So we get the value x is less than or equal to 5 by 2. That is, x is less than or equal to 2.5. In both ways, we will get the same result. You can see, same result. Now I will read question number 8. Look at the text. Find the smallest value of x for which 5 minus 2x is less than 5 and 1 by 2 minus 5 by 3x, where x is an integer. Okay, we can solve. You can see 5 minus 2x. This mixed fraction, convert this mixed fraction into improper fraction. 5 and 1 by 2 can be written as 5 into 2, 10. 10 plus 1, 11. 11 by 2. And now you can transpose this minus 2x to the other side for avoiding negative sign. When we simplify, you can understand. Now transpose 11 by 2 to the left side. You will get, take LCM and simplify on both sides. You will get 10 minus 11 by 2 less than 6x minus 5x by 3. When take LCM, 3 is the LCM, 3 into 2, 6x minus 5x. Okay. Now 10 minus 11 minus 1 by 2. Minus 1 by 2 is less than 1 by 3x. Now transpose 3 to the left side, we get minus 3 by 2 is less than x. What is minus 3 by 2? We can convert this into decimal fraction, that is minus 1.5. That is minus 1.5 is less than x. We can write it in another way. X is greater than the same thing. You can see the same thing. X is greater than minus 3 by 2. That is, x is greater than minus 1.5. And x belongs to in that question, it is for which find the smallest value of x is an integer. X belongs to integers. So which are the values? X belongs to integers. So x is greater than minus 1.5. So you have to remember that number line. X greater than minus 1.5. So the answer is minus 1, 0. You can see one number line. Suppose number line. You can see one number line here. It is a number line. X is greater than minus 1.5. Minus 1.5 is here. So x is greater than means minus 1. X may be minus 1, 0, 1, 2, 3, 4, 5, 6, etc. 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 So these are the values. Now we can see next question. Question number 11. Given x belongs to integers, find the solution set of minus 5 less than or equal to 2x minus 3 less than x plus 2. That is the question. Here you can see two inequality signs. Two inequality signs you can see. So you have to split this inequations like this. First one, minus 5 less than or equal to 2x minus 3, 1. And 2x minus 3, the other one, 2x minus 3 less than x plus 2. In this way we can split it. And you have to solve both sides like this. This one, transpose minus 3 to the left side, it becomes minus 2 is less than or equal to 2x. It becomes minus 1 is less than or equal to x. Here, when you simplify this, transpose x to the left side, minus 3 to the right side, then you will get x is less than 5. And in the same way, you can combine these two solutions. From where we can start? Minus 1, we can combine these two in this way. minus 1 less than or equal to x, here also x, less than 5. In this way we can combine minus 1 less than or equal to x less than 5. Both inequations you can see here. I will show that. Look, minus 1 less than or equal to x, that you can see, and the other one x is less than 5, both you can see here, and x belongs to integers. Now, so the values of or range of values of x are minus 1 to 5. Okay, and x belongs to integers. Therefore, which are the numbers or elements in that set? Minus 1, 0, 1, 2, 3 and only up to 4 less than 5, not less than or equal to 5. Therefore, we can write up to 4. Now, let's see how can we graph the solution set. Suppose in this question is graph the solution set on a number line. Now, how can we express the solution on this number line? That means representation of the solution on a number line. Here, suppose x belongs to integers, only these numbers are the solution set. Okay, so draw a number line and mark like this or darken this circle. Okay, in this way we can represent the solution set on a number line. Now, suppose the solution set is x less than 2 and x belongs to real numbers. Real numbers means all the numbers, fractions, decimal fractions, all these things. Now, how can we express? The same thing, you can draw a number line as usual and x is less than 2. So, encircle this 2, encircle 2 and no need of darken it. But this line, anywhere the value, all these are the values of x. So, darken this line, at the same time the left arrow also, left side arrow also you have to darken. In this way you can represent. Now we can see one question. Represent the following inequalities on a real number line. Consider one question. 2x minus 1 is less than 5. Okay. Now simplify, solve it. You will get x is less than 3. So we can draw a number line, solution set. First we can write solution set. That is better. Solution set is, since x belongs to real numbers, so we can write the solution set in set builder form only. We cannot write the solution in tabular form because all these numbers, all these are the values. We cannot express all the values of x in here as the solution set. So we can express it as set builder form. So solution set is x such that x is less than 3, at the same time x belongs to real numbers. Now draw a line, number line, and 3 is not included, therefore not darkening that circle, and left side, left line, at the same time left arrow also darken. And the value is 3, x is less than 3. At that time in the number line you have to mark one more digit. That means up to 3 is here, so you have to mark 4 also here. That is a must. Okay? Otherwise you will not get mark for this number line. And in this way also you can mark. You can see 3 is not included, so therefore we can draw a curved line here and darken up to this, or shade. We can give shade. We are usually using this form. Okay, in this way also you can show. And one more question there. 2 into 2x minus 3 is less than or equal to 6. Solve it, and x belongs to real numbers. Transpose 2 to the other side. Therefore, 6 by 2, that is 3. Again, transpose 3 to the other side. Now, x is less than or equal to 6 by 2. That is, x is less than or equal to 3, and x belongs to real numbers. Same question. Here you just darken 3, you will get this result. Look here, you can see the difference. Here 3, 1, 2, 3, etc. You have to write 4 also. In this way also you can represent. Here 3 is also included, less than or equal to 3. Therefore, it's a straight line here. Draw straight. One more. Suppose the solution is, question number 7, minus 5 less than x less than or equal to minus 1. How can we represent it? Draw a number line as usual, 0, 1, 2, this much enough. And left side, anyway we want to get up to minus 5, therefore one more number should be there. Minus 5 is not included, so draw a circle here, not darken. But minus 1 is included, so encircle 1 and darken this circle and this part also. This way we can represent. Now we can see one more question. Question number 6. List the elements of the solution set of the inequation. Minus 3 less than x minus 2 less than or equal to 9 minus 2x. X belongs to natural numbers, set of natural numbers. Therefore, write this equation and split. Here you can see two inequality sign. Therefore, split this inequation like this. Minus 3 less than x minus 2 and x minus 2 less than or equal to 9 minus 2x. And solve both sides. You can solve it by yourself. When you solve, on the left side you will get minus 1 less than x, and the right side x is less than or equal to 11 by 3. What is 11 by 3? It is 3.66. Now combine these two. From here we can start. Minus 1 less than x less than or equal to 3.66. In this way we can combine. X belongs to natural numbers. Because x belongs to natural numbers, so we can write the solution set in tabular form or in set builder form, both are correct. Anyway, in tabular form, when you are writing in tabular form, you will get the result, solution set, minus 1. X belongs to natural numbers, so it starts from 1, 2 and only up to 3. 3.66 is not a natural number. Therefore, we can write these numbers only, 1, 2 and 3. If we write it in set builder form, how can we write the answer solution set x such that minus 1 less than x less than or equal to 3.66 comma x belongs to n, close this curly bracket. This is also solution set in set builder form. And you can represent these values on a number line. Next question. List the values of x. Question is minus 2 less than or equal to 1 by 2 minus 2x by 3 less than or equal to 1 and 5 by 6. X belongs to natural numbers. Same type of question. And graph the solution on a number line. You can split this like this and on the left side when you solve, you will get left side becomes x is less than or equal to 15 by 4. That is, x is less than or equal to 3.75. When we simplify the right side, we get, you can see all steps taking LCM and simplification. When we do, right side becomes minus 2 is less than or equal to x. Now you can combine these two. From where we can start? The smallest number, minus 2. Here we can start. Minus 2 less than or equal to x less than 3.75. Both you can see here. One is this. Minus 2 less than or equal to x. At the same time, x is less than or equal to 3.75. And express this on a real number line. Now see, next question. Solve and graph the solution set. First is 2x minus 9 is less than 7 and 3x plus 9 is less than or equal to 25. Simplify left side. 2x transpose minus 9 to the other side. You will get x is less than 8 and both should be satisfied. You can see right side x is less than or equal to 5 and 1 by 3. When you solve this, you will get. In both cases, we cannot combine. Look here, x is less than 8 and at the same time, both should be satisfied. X is less than or equal to 5 by 3. How we can combine these two? So the value is only up to 5 and 1 by 3 because and is in between. Okay, both should be satisfied. Therefore, the solution set is x such that x is less than or equal to 5 and 1 by 3 and x belongs to real numbers. And we can draw a number line like this and the value of x is less than or equal to 5 and 1 by 3. So find a number in between 5 and 6, 5 and 1 by 3 and at the same time darken circle and at the same time you have to write that 5 and 1 by 3 there. You can see here in the second figure you can see that clearly. Look here, in between you can draw the circle and darken that circle. At the same time you have to write there 5 and 1 by 3, otherwise you will not get mark. And darken this line at the same time left arrow also. So this is the result. Another question, solve and graph the solution set. Another, look here, in between there is or, that is the difference. You can see 3x minus 2 is greater than 19 or 3 minus 2x is greater than or equal to minus 7, x belongs to real numbers. You can see 3 left side. When you simplify, you will get x is greater than 7. And on the right side, you will get, when you simplify, you will get 5 is greater than or equal to x. Okay. So, or either x is greater than 7 or x is greater than or equal to 5. Okay. Not and. No need of combine. Either or. Therefore, the solution set is x such that x is greater than 7 or x is less than or equal to 5. X belongs to real numbers. Therefore, both we can express on the same number line. You can see here a number line. X is greater than 7. Here you can see x is greater than 7. This part. On the left side, x is less than or equal to 5. You can see that. Okay, in this way we can express. So today we learned about an inequation and the rules for transferring the terms from one side to other sides, and solving the inequation algebraically. Okay, thank you.